Inequalities Lesson 5. In Lesson 4, we proved for any non-negative real numbers a and b, a plus b divided by 2 is greater or equal than the square root of ab. The simplest form of arithmetic geometric mean inequality for two real numbers. Equality holds when a and b are equal. In this lesson, first we prove arithmetic geometric mean inequality for three non-negative real numbers, and then we use induction and prove it for n non-negative real numbers. We want to prove a plus b plus c divided by 3 is greater or equal than cube root of abc when a, b, and c are greater or equal than 0, and equality holds when a, b, and c are equal. In our previous lesson, we proved for any three real numbers a, b, and c, a2 plus b2 plus c2 is greater or equal than ab plus bc plus ca. We know x3 plus y3 plus z3 minus 3xyz is equal to x plus y plus z times x2 plus y2 plus z2 minus xy minus yz minus zx. This can be proved by expanding the right side of the equation. Since x, y, and z are non-negative real numbers, then x plus y plus z is greater or equal than 0. x2 plus y2 plus z2 minus xy minus yz minus zx is also greater or equal than 0 based on the inequality that proved in lesson 4. Therefore, x3 plus y3 plus z3 is greater or equal than 3xyz when x, y, and z are non-negative real numbers. If we assume x3 is a, y3 is b, and z3 is c, we have a plus b plus c greater or equal than 3 cube root of abc for a, b, and c greater or equal than 0. Equality holds when a, b, and c are equal. Now we prove arithmetic geometric mean inequality for n positive real numbers. We call it Pn, and we prove Pn is true when n is a natural number. The base of induction is already proved for n equals 2 and n equals 3. We already proved Pn is true. Second step of the induction is if Pn is true, then P2n is true. That means if arithmetic geometric mean inequality is true for n, then it is true for 2n. And the third step is if it is true for n, then it is true for n minus 1. This induction is done by Cauchy. It's a very special way, and let's prove the steps, and we have some numerical example to understand it. The second step is if Pn is true, prove P2n is true. That means a1 plus a2 plus a2n is greater or equal than 2n square root of the 2n root of a1, a2, a2n. This is what we want to prove. We divide this series in two parts, each of them n terms, the first and the last n terms. Then we use arithmetic geometric mean inequality for the first n terms and the last n terms. Now we use arithmetic geometric inequality for two terms, and we have 2a1 plus a2 plus a2n is greater or equal than 2n root of a1, a2, 2n. If you multiply these two and take square root and times it by 2, you have the other. The last step is assuming it is true for n and prove it is true for n minus 1. We know it is true for n numbers. That means a1 plus a2 plus an over an is greater or equal than n root of a1, a2, an. we assume an is n minus 1th root of a1, a2, an minus 1. Therefore, a1 plus a2 plus an divided by n is greater or equal than nth root of a1, a2, an minus 1 times n minus 1th root of a1, a2, an minus 1. We know nth root of x times n minus 1 root of x is the same as let me read it this way, the nth root of x times the nth minus 1 root of x is the same as, we take the common denominator between 1 and 1 over n minus 1, we have n over n minus 1. Therefore, this can be written as nth root of a1, a2, an minus 1 to the power of n over n minus 1. This means a1 plus a2 plus an over n is greater or equal than nth root of a1, a2, an minus 1 to the power of n over n minus 1, which is the same as nth minus 1 root of a1, a2, an minus 1. Therefore, a1 plus a2 plus an over n is greater or equal than an. We multiply both sides of this inequality by n. a1 plus a2 plus an is greater or equal than an. We bring an to the other side and divide it by n minus 1. We have a1, a2 plus an minus 1 over n minus 1 is greater or equal than an. To understand what we've done, we say it is true for 2, therefore it is true for 4, 8, 16, and so on, because of the second step. Now, since it is true for 4, it is true for 3. Since it is true for 8, it is true for 7, then it is true for 6, then it is true for 5, and so on. Thank you.